The new LLaMA 3 model is finally out. It's the best open source LLM so far. And today, we will take the 8 billion parameter model out for a test drive. This video is part of the Gen AI and LLM project series. Make sure you check it out. And all the concepts that you need to understand the projects in this series are going to be in the LLM concepts playlist. Make sure you check that out as well. In today's video, we will use LLaMA 3 in multiple scenarios and judge its performance. But to be able to do that, we need to import it and run it on Google Colab. So I've done that, and I'll explain every line to you for this Colab file. And we'll also leave a link to this Colab file in the description of this video. So let's jump right in. The first line installs the Hugging Face Transformers library from its GitHub repo. The !pip command installs Python packages, and the -q option is for quiet mode to not clutter your Colab file with output messages. But with the quiet mode, if there's an error, that will show up. The next line installs datasets, LoRaLib, both of which are required for fine-tuning. LoRa is a type of fine-tuning technique, and dataset enables you to fine-tune with custom datasets. Sentence piece is a tokenizer. Tokenization, as you know by now, is when we divide text sentences from prompts into individual tokens for ease of processing by an LLM. This next line installs bits and bytes, Accelerate, Xformers, INOPS, which are used alongside the Transformers library. Accelerate is used for accelerating computation, Xformers is for transforming models, and bits and bytes is for manipulating data. Finally, we install the HF transfer package. This just speeds up file transfers with Hugging Face, and we definitely need that since we're going to be importing a huge model. In this cell, we utilize the IPython Display module to render markdown content in Colab. I mean, it can be used to render rich outputs like HTML, images, videos, but we need it for markdown in this case. Then, as you can see, we are using the display function to write LLaMA 3b using markdown as a title, since we've used a hash in front of it. Here we've just displayed some information about our NVIDIA GPU. The NVIDIA SMI command queries the GPU and shows information about it. In this cell, we're importing a bunch of things again. OS gets us the OS module, and because my channel has a lot of Golang and Rust engineers, so in case you're new to Python, this package does almost the same thing as the OS package in Go, which provides you with a way to interact with the operating system and do stuff like accessing environment variables, working with files and directories, etc. Torch obviously is the PyTorch library, which provides us with tensors, dynamic neural networks with strong GPU acceleration capabilities. At the top, we had copied transformers from GitHub, and now we are just importing it because in the next line, we need the auto tokenizer and auto model for causal LM. Where we've already seen auto tokenizer in the Mixtral video, which is a part of the same Gen AI and LLM videos playlist, which today's video is going to be a part of. So the auto tokenizer helps us automatically select the appropriate tokenizer for a given model architecture. And auto model for causal LM helps us automatically select the appropriate pre-trained model for a given task, which in our case is a model suitable for causal language modeling tasks. Then we set the HF hub enable HF transfer to 1 to activate transferring of models from Hugging Face hub. Then we set the default device for PyTorch tensors to be the CUDA device, if available, which is basically enabling us to use the GPU. And in this cell, we import Torch, then pipeline from transformers. And for any inference task like natural language processing, pipelines are quite handy, and they're available in the transformers library. In the next line, we create a text generation pipeline, and we call it pipe. We mention the task, which is text generation. We mention the model name and the model arguments. Now it says float 16, and this reduces memory usage and speeds up computation compared to the default data type, which is float 32. Then we mention CUDA to ensure the model runs on GPU. Now in this cell, we have some code that will help us define our messages, prompts, and outputs, basically for guiding our interaction with the LLM. So we start with defining messages, which is a list of dictionaries, or if you're from JavaScript, it's basically just an array of objects. So first we have a system message where we're informing that it's a friendly chat bot who responds in the style of a pirate. And the next is a user message who's asking the model, who are you? Then we craft our prompt containing these messages. Terminators help with the EOS token, which specifies the end of sequence. The output we get from our pipeline is captured in the outputs variable. Here you see that we have the prompt and the maximum number of tokens to be used. And this specifies how many words do you want the LLM to use in the response. If this is large, it's going to take a lot of time and computation. So if you're just experimenting, keep this low, but don't make it too low, otherwise you won't get a sensible response. So to have a fair test, we usually keep a value of 200 or more. And the temperature is 0.6. The closer this is to 2, the more ambiguous the output will be. And the closer this is to 0, the more deterministic the output will be. Then we access the values of the generated text from the outputs variable, and we store it in generated outputs variable, which is what we print out in the next line. So here we see the interaction with the LLM. And let's check out what the LLM says when asked, who are you? It says, shiver me timber, me name be Captain Chat, the scurviest chatbot to ever sail the seven seas. So now it's able to understand its role as a pirate and contextualize the information we gave it, which was you're a friendly chatbot who always responds as a pirate. And it also answers the question, who are you? And this is quite smart. Now, as you can see, our text is going all over the place. So this cell has some boilerplate code to help us wrap our text for a specific width. In the next cell, we define a function called generate. And this function is what we're going to be calling a lot in the rest of this code file. We start by generating the system prompt, and we set it to say, you are a friend and a helpful assistant. And then we define the messages object. And just like we did earlier, we're going to craft our prompt with the messages and terminators. We're then going to generate the output with the prompt. And the max token size, which in this case is equal to max length, which is going to be assigned dynamically. And then we have temperature values and going to access the generated text from the outputs object. Then we perform the wrapped text operation that we defined above. And finally, using the display function from the IPython Display module, we're going to print out this whole thing in Markdown. And this looks quite neat, as you can see in the output below. Now, every time we want to run this function, we just have to call the generate function with the prompt and the max length. So let's check out our first example. We ask it to write a detailed analogy between mathematics and the lighthouse, and you get a nice detailed output. The second example is the same, but without a system prompt. Then we ask it the difference between a llama, vicuna, and alpaca model and get a nice answer. We then give it a real-world task, which is what these LLMs get used for. We ask it to write an email to Sam Altman, given reasons, to open source GPT-4. The next example is the same, but has a different system prompt and asks Llama to behave like a 5-year-old who's scared that AI will take over. The next example is also same, but we ask it to behave like Kate, the vice president of USA. Now, after a few examples, we have some code generation exercises for the model, and I'm quite impressed with it. Then we have some logical questions, and you can check out this file in detail, but long story short, it does beat out some of the best models out there in logical reasoning. Then we try out some large prompts, and it still works out quite well. In my opinion, this is almost as good as GPT-4. So we've seen the model and its capabilities in a detailed way, along with the code. Now, I just want to tell you about my Golang AI course. So if you're a Golang developer, you cannot miss this course. And the link of this course is in the description of this video. So in this course, we'll build 6 awesome real-world production-level applications with Golang that use AI at the core. And 2024 and beyond, AI is going to be huge. And if you're looking for a new job or a raise, you better know how to build AI-powered applications, because the entire industry is looking for a revamp and using AI in their projects. So don't miss out. If you're new to this channel, you got to check out the 55 Golang projects and the 50 Rust projects playlist, where you learn by building projects that are in the increasing level of difficulty. There's also the technical architecture course and the system design course, which you might like. All of this awesome knowledge is for free. Don't forget to like and subscribe and share this with your friends if they're interested in tech. You can also join our free Discord community and come hang out with all of us. We discuss job opportunities, new tech, and simply chill out. All of the members are super intelligent tech bros, and you'll totally love it here. It's the best place to make friends. All right, thank you so much for watching, and I'll see you in the next video.